Hello, student. Today, we will practice deep learning. Uh, I will illustrate that. I will illustrate deep learning with Black-Scholes model. Basically, what I want to do is re-engineering Black-Scholes model with deep learning. So let me use Google Colab. So colab.researchgoogle.com/hashtag create new. Okay. So file name BSM reverse engineering. Yeah, so text, okay. We will reverse engineer BSM formula with deep learning. And of course, first we have to know what is BSM formula. BSM formula is basically, let's say, for core option. So for core option formula is core option price equals basically B multiplied by F multiplied by F multiplied by N D1. I'll explain later what those notations are in detail shortly. And then minus exercise price minus K multiplied by N T underbar 2. Okay, looks like this. This multiplication is not so pretty, so let me change everything into comma dot. Okay, so this is basically call option price, and then put option price is, again, we have to discount something inside of the parentheses, and then K multiplied by N minus T underbar 2 minus F and minus T underbar 1. Okay, so this is put option price, call option price, and put option price. Looks like this. Okay, so let's do the coding. So define, okay, okay, European underbar option, and then we have a bunch of course, bunch of input variable, but let me fill later. So use the formula so that, yeah, B multiplied by core price, okay, result, let's say result equals P multiplied by F multiplied by NT1 minus K multiplied by NT2. Okay, this is the result, but this is a core option. So if core option, if we are interested in getting core option, then result is this one. Otherwise, if call option equals 0, otherwise, then we want result equals B multiplied by, multiplied by K multiplied N minus D2. We have to define those variables shortly. Minus F is for the price, and minus D1. Okay. And then this function return B. Actually, yeah, I think this is not necessary. So let me say B multiply result. We discount it back by result. Okay. Then here we need an argument about core option, right? Core option. Let's say default is 1. Okay. And then actually in the option price, we need other input like stock price. I will explain them shortly. And then TRD. And then the most important one, sigma. Okay. So we have a bunch of variables we need to define. So here, F is basically S multiplied by exponential NP dot exponential minus, not minus, actually, R minus D multiplied by T. Okay, so clearly we need to import numpy as NP. Okay, here. So for input variable, S is spot price, and then K is strike price, right? And then T is time to maturity, years, unit is years. And then R is risk-free rate, unit per year, okay? And then D is here, D is dividend rate per year. And the sigma, the most important one in Black-Scholes formula, is volatility per year, okay? And then call option is 1 if call, and then 0 if put option, okay? And then F looks like this, and then F is basically called forward price, okay? And then we need K, D1, D2, okay? Actually, we have B, so let me define B first. B is basically discount rate here. So NP, EXP minus R multiplied by T. This is basically discount factor. It transforms the value of a contract. It comes with the value of a contract that pays $1 at time T times later, okay? T years later without default risk. And then we have F, and then we need to define T1 and T2. We have to define T1 and T2. T1 and T2 is a bit slightly long, okay? But here it is first NP log and F. Okay, F divided by K. Okay, and then plus 0.5 multiplied by sigma square, and then multiplied by T. And then let me copy D2. This one is here, almost same, but this is minus. Okay, and then we have to divide, multiplied by sigma multiplied by T to the power of 0.5. Okay, and this is same. And here we have n. So we have the n function. N is the cumulative CDF, cumulative distribution function of standard normal distribution. So we have to define n over here. Let's define n over here. So define nx. Okay, nx, and then this is basically return si. Okay, we have to import. Okay, import this scipy and then stat as si. Okay, and then from si I will call normal distribution and then CDF. Okay, CDF and then x, and then let's say mean is 0, and then of course variance is 1. Okay, so this is the CDF for standard normal distribution. So I think we are set. So let me test the value. Let me test the function. Let me change the runtime as the change runtime type. Okay, GPU. Okay, and then let me test the code. So let me European underbar option, and then let me test. Okay, let's put value so that let's say it is the 30. Let's say K is 50. T is 1 year. And then risk-free rate is about 0.015. Dividend rate is, let's say, 0.01. Sigma is 0.3, 30%. And then put option. European option. European option is not defined. European option not defined. And then, okay, I think this is right. And let's continue after the break.